Hello, 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 and yes, welcome to the One Line Code at 50,000 subscribers special. I'm just going to make sure everything's up and running and working first. So let me just stop the preview that I can see on the screen here. And please let me know if you can hear me or not. That would be a good start. Well, you've got definitely sort of big Javid at the moment. It's a bit different to set up things for YouTube than Twitch. Anyway, yes, 50,000 subscribers, and I mean, who would have thought 50,000 subscribers? And as has become tradition on the channel, I like to do a little bit of a live stream, and it's a bit more special on YouTube than it is on Twitch because we have a lot more people. Well, potentially a lot more people. I guess we're up to a handful now, certainly. So hello, everybody there in the chat. That's brilliant. I will point out that if you ask questions in the chat and I miss them, I do apologise. I've got some mods in there as well, keeping an eye on things. Anything... Somebody says the mic is muted. Okay, good. But I'll be hanging around afterwards if anybody wants to ask questions or have a chat. So what we're going to do today is, let me find the right screen to start with. We're going to celebrate by programming a puzzle game, and I like the game Bejeweled. And you might have seen this game. Let me actually put it on the right screen so you can see what I'm seeing. There we go. So, Bejeweled, if you don't know, is a game where you've got to match at least three gems, either vertically or horizontally. And if you do that, then they disappear. And if you get 4, they disappear and leave a bomb. And if you get 5, even better, you get higher scores, etc. But I like the game. Not only is it very addictive, but, and let's be honest, it's simple enough for me to program in just over an hour or so or whatever for this live stream. And definitely a reason for that. But it's an interesting examination of how do you handle sequence and order in a game in a way that makes sense. So I think there's some educational value to it as well as being entertaining. Now, I will be stopping periodically to look for questions in the chat. So there's quite a lot of people here. Wow. Okay. David, what do you think about making a game like Age of Empires? Yeah, I'll just knock that up next week. So, one of the things I will point out before we start, and I'll just put it into the chat, is that the prize draw is still open for a couple of hours. So here is the links. You can enter by filling in the form, and I will point out that there is actually some prizes. If you didn't see the little preview video, the prizes are 2 $50 vouchers for GameDeveloperStudio.com, which is a whole load of great graphics and assets for your games. And there's going to be, at random, lots of keys given out for the game Cheeky Beetle, which is created by a single programmer. And I think it's just a fantastic example that if you really put your mind to it, you can develop these things and get them to market. So thank you to both of these guys for helping out celebrate the 50k. Right, that's the advertising done. So what we're going to do is program the game Bejeweled. Well, at least a model of the game Bejeweled. Because there's a lot to it. There's puzzle modes, there's continuous mode and all that. But what I thought would be useful is to come up with a framework where we can have something like this to select the gems and move them around and get some fancy explosions. And periodically I'm going to be stopping just to glance at the chat over here. Make sure people are behaving themselves. So hello to all the people saying hi. There's quite a few. Oh, thank you very much. I know there's lots of praise. And I like doing these live streams on YouTube to celebrate the milestones because it's the core audience. The people that are here now are the people that are genuinely into the content of the channel. So hopefully it shouldn't be too disappointing. I should point out there's no flare, there's no balloons. I know it's a live code party. And you are more than welcome to try and code along because I will be coding from scratch. It's not a cut and paste job today. But it probably will be moving at a little bit of a pace. So I guess that's all I've got to say at the start. So let's just crack on with it, I think. And because I'm celebrating the channel, and the channel has been predominantly OLC console game engine, we're going to do this in the console game engine. Now, it's also live. I have to make sure I get all the right windows here. Hang on a sec. It's also live, so we're going to end up with bugs and glitches and debugging, I'm sure. I have got, as has usually the case on these live streams. I've got a set of notes that I'm going to be working off to try and help me along and to make sure I don't sit around stumbling too much. And I'm also going to be drawing some stuff like I normally do in OneNote to explain some of the concepts that we're doing. So I'm presuming you're all familiar with the concept of the game Bejeweled. I guess it's also similar to Candy Crush and all of those other little addictive mobile games, which everybody hates, but actually everybody secretly plays, I think. They're quite good fun. But let's get started. And we're going to start just basically we need to create a console game engine application. So here you can see I've got an int main and not much else. So now I have to put myself into console game engine mode because I've been using the Pixel game engine for about the last 8 months. But let's keep going. So we want to create a class and we're going to derive it from the console game engine. And we'll call it gems, simply enough. I've got to remember all of the little nuances as well because there's no namespaces and things. So we'll create a class. Let's move that pen out of the way. Oh, see, straight away already get some typos and things. It's nowhere near as posh and well edited as the videos, he says. So we'll give that a constructor. Gems. And we also need to give it a name, and it was MS app name in the console game engine. And don't forget, the console game engine did everything in Unicode, much to most people's displeasure. But what hey, 50k subscriber gems. There we go. So that's going to be the name. And we need to override 2 functions, as we always have done. The first is onUserCreate. That returns a bool. And I'll just make it return true to start with. And the second is onUserUpdate. When I can start typing. My fingers haven't warmed up yet. We'll get there, we'll get there. And that takes in elapsed time, which is the change in time between the 2 frames. And if either of these methods return false, then the game will exit. So I'll just force them to return true for now. So that's a skeleton application, and what we'll need to do is alter our main. I'm just looking at some of the comments coming back. Some people are turning up late. What did you do? We're going to be making a matching gem game. We've got to match gems in a row, horizontally or vertically, and they're all going to collapse into each other, and you've got to try and work out what the winning combinations are in order to get rid of the most gems, I suppose. It's as simple as that. But we won't probably get it finished to a really polished game tonight, but what it should be is a nice starting platform for other panel-based games of this nature. So in my main, I want to create, and I did make a note of what was a sensible resolution here. Right, because it's quite low resolution. So there's my class, and we'll call it game. And we want to call the construct console function. So if game.construct console, and the console I'm going to be creating is only going to be 64 pixels wide by 64 pixels high. And each pixel is going to be 14 by 14 screen pixels, so it's really low resolution. If that's successful, then we want to start. Do you know what? I've already gone straight into Pixel Game Engine mode here, haven't I? I called it gems for a start, because I can't remember if the construct console actually returns a boolean. Oh, come on. There we go. And that should be game. Ugh, right, we'll get there, we'll get there. Right, so let's just make sure that that compiles and runs first. And I'm using the Visual Studio Community Edition. Mine's 2017, so that's running. Console Game Engine is up and running, and we can see the frame rate ticking over at the top. Good. Give a quick glance at the chat. Surely you do not need a second public declaration. You're absolutely right, you don't. This is a little bit of a mental trick that I like. It just helps me partition the different functions that I'm using in my class description. Because I'm going to be doing all of this in one file, it's just for me, it's like a little mental kick to say, these aren't constructors, these are going to be functions. That's all, but yes, you don't need them both. Any tips from you as an experienced programmer is, well, you've just got to practice, and that's the crucial thing. You've just got to keep sticking at it. It's a lot of hard work. Right, so we want to draw something. Now, why have I chosen such a low resolution here? 64 by 64. Well, that's because in the Bejeweled game, we'll just have a look at the reference photograph here, there is 8 by 8 gems. And so I'm going to have the same, and I'm going to have all of my gems to be 8 by 8 pixels. So 64 by 64 makes it quite nice. I don't have to worry about some sort of surrounding frame. So I think that's probably where I'll start. Let's draw out the playfield. Well, I'm going to need some gems to start with. So what are my gems going to do? Well, they're going to be sort of different colours and things, and that's quite important. So I'll create a struct sGem, and in the console game engine, colours are represented as shorts. I'll call that colour. I don't need to know the position of where the gem is because I'm just going to store them in a two-dimensional array. That's all I've got for now, is the colour of the gem. Let's just try and get it to draw things in the right order. So down here, whenever we're drawing something, probably the first thing we're going to want to do is clear the screen. Now in Pixel Game Engine that's the clear command, but in Console Game Engine it's fill. And we want screen width and screen height. If anybody is coding along, do shout out. And I want to fill it with a space, which is unusual again, and the colour doesn't really matter. So that's going to set everything on the screen to be black, effectively. But then I want to draw the field, so let's put a comment in there so we know what we're doing. So all of the rendering is going to happen at this point. And all of the gameplay stuff is going to happen before we do any rendering. Just trying to break up the project. And so we want to draw the field. Well, what are our gems going to look like? I could just use coloured rectangles, but why not try and do something a little bit more gem-looking, for example? And now in the console game engine, unusually, all the sprites are strings. So I'm going to include, and again we're in Unicode mode here, a W string, which is going to firstly represent a sprite for a gem. There we go. And I think we'll use onUserCreate to try and populate what a gem should look like. What should a gem sprite be like? And I'm going to do that by assembling a string, because it's the console game engine, don't forget, of pixels to represent either the pixel is there or it isn't. So let's have a look. So I want a string, and it's going to be 8 by 8 pixels, so 1, 2, 3, 4, 5, 6, 7, 8. There we go. And it's going to be 8 across by 8 high. 1, 2, 3, 4, 5, 6, 7, 8. Excellent. Let's have a quick glance at the chat. Will I ever cover ray tracing? Maybe. I've got some other plans before I do more graphics, I think. So I want to fill this in with something that looks like a gem. And I'm going to use dots are going to represent transparent characters, and X's are going to represent solid characters. The colour is irrelevant here because the colour is stored as an additional variable in our gem struct, and so when I'm using this string to define what the shape should look like, that's when I'll choose to colourize it. But let's fill in something that looks approximately gem-like. And as you can tell, I am not that keen on drawing things ever. Do you know, I'm going to press the insert key, which you can't do in VS Code, I should point out, and just colour them in this way. So I want a little hole in the middle. I did sort of pencil out what I want the gems to look like beforehand, because it wouldn't be a particularly interesting stream if it was me just fumbling about trying to make all of this work for hours and hours and hours. So that's what my gem is going to look like. Good, so I've got a gem. I'm going to take it off the insert key now. And I'm going to need a playing field for all of my gems too. So I've got the struct, but I'm just going to create a standard 2D array. I'm going to call it gems. And there's going to be 8 by 8 of them. Now, not very often you see me using 2D arrays, but in this game I don't really see any need to ever dynamically allocate anything. Everything's going to be fixed. The playfield is always full of gems. They move around a bit, but there's always going to be 64 gems on the screen at any one time. So I'll use a 2D array, and it might make some of the indexing easier. Usually we would do y times width plus x to access a 2D array, but maybe we'll try this and see how we go with it. Every time I look up here, I'm glancing at, some of my notes, but also the YouTube chat. Looks like an old Chinese coin. Well, maybe we don't call it bejeweled, we call it old Chinese coin instead. So I've got my sprite of a gem there, but now I want to draw the field of gems. Because basically that means I'm going to have to iterate through my structure of gems, where we go in draw field here. So I need 2 nested for loops just to get these drawn. And it's nice working with fixed constraints all the time, because I don't need to have hundreds of variables to do anything. For int y equals 0, y is less than 8, y plus plus. Now, we'll come to the game logic in a little bit. I just want to get sort of the very first things out the way, so get the visual stuff dealt with first. So now I'm going to scroll through my whole structure of gems and just draw them. Now, I don't have sort of an immediate two-hand draw sprite function, so my intention is to go through the sprite of characters we've just created and draw those. So I need another 2 nested for loops. Int I equals 0, I is less than 8, I plus plus, nice and simple. And j. So these are going to represent the coordinates inside the gem sprite. And I don't want to draw a pixel if that part of the sprite is transparent. Well, because you don't want to draw it, do you? It's transparent. But if it's an X, I do want to colorize it. So that's what I'm going to do. And I'm going to use the draw command to locate, firstly using X and Y where on the screen it is. And don't forget the screen is 64 by 64, so it's X times 8 plus I, and Y times 8 plus I. Not I, j, sorry. And then I want to decide which particular gem to draw. So I've got my array here of gems. In fact, I made it 2D, didn't I? So I can just go X and Y. So that's going to be the gem. And that's going to be the colour, which I have to remember in Pixel Game Engine is not quite the same. But I only want to draw this. Put in a pixel solid there. Oh, getting all of my game engines mixed up. That's where you get to. You need to practice with one and then the other. So that's going to draw the individual pixels of the sprite. But I only want to do that if it's transparent, or if it's not transparent. So I need to check for that. And to do that, because I've stored my sprites as a string, I need to access the string at the correct location to tell is it transparent or not. Fortunately, that's quite easy. So if the sprite of our gem j times 8 plus I, is that the right way around? Should I do it that way around? Yeah, yes, because j is effectively y here, plus I, which is effectively our little mini x. If that location in the string is equal, so is not equal to a full stop, so it's the other character, it's the x, that's when we want to draw the gem. Right, so let's just have a quick recap. A little bit confusing to start with, but we've got an 8x8 field of gems, and we've defined an 8x8 string which represents what a gem should look like when we draw it to the console. So here I'm just iterating through all of the gems in my array, and for each gem I then need to iterate through each of its pixels in order to work out how to draw it. And I'm just going to draw it based on the gem's colour. But we've not set any of these things yet. So I need to initialize my gem array with some useful information to start with. So I'm going to go back up to onUserCreate and populate the gem array. In fact, I'm going to need for loops again. So I'm just going to borrow these from down here and put them there. And so for each gem, I'm just going to choose a colour at random. Now, there's some little console game engine quirks here that I've got basically 8 colours to choose from. But I want to use the more vibrant ones, so I need to offset them into the top 8 of the colour range. Now this will confuse a whole load of people that have only ever seen the channel doing pixel game engine stuff. Because we're working in the console, we have far fewer colours to choose from, and they go in order of being dark primary colours, secondary colours, to light primary colours, secondary colours. So I'm choosing here a random light colour. Yeah, it'd be good if anybody is coding along. Right, so I've now got an array of gems. Let's see what happens. Let's compile it. See if we're getting into the flow of things. Well, it compiles. That's a good start. Oh, there we go. So we've got an 8x8 field of our sprites of all different assorted colours. That's very nice, but we've got no means of interacting with it. We've got no means of actually playing any game. There's nothing. It is just simply drawing the gems on the screen. Good. So that's quite nice. Not much code so far. Yeah, thank you to Rui there for pointing out what people are doing, and thanks for all of those shouting out messages of support. I appreciate that. Right, let's keep moving because we've probably got quite a bit to get through. So in onUser update, we need to start thinking about the gameplay. And this is where I want to introduce the idea of using a state machine, because there's a few things we need to think about. It's no good if the player just moves the gems around and the screen immediately changes. The player needs to understand that their actions have consequences in the game, or else it'll be very difficult to play. So if I swapped 2 gems, let me just run this so I can demonstrate. So, for example, I could win here by swapping this pink and this yellow gem to form a line of 3 pink gems. But if I did that and they just disappeared, and then subsequently the other gems fall into the holes and they may form their own chains of winning and just disappear themselves, just simply by changing these gems around, the whole screen could change and the player would have no idea why. So this implies that a sequence of events needs to happen, and the player needs to be informed of this sequence. And whenever you've got sequences, you need timing. And timing is always a little bit tricky when you're working with computer games, unless you start implementing some sort of state machine. And why is timing tricky in a game setup like the one we've got here? Well, if I wanted to add delays, so for example, I want to swap the 2 gems around, I want the player to see that they've swapped the 2 gems around. So I need to actually delay the gameplay and let the player accumulate that visual change in order to understand what they've done. And when you start adding delays in, there's 2 approaches. One is you just throw a delay in. You make your process go to sleep. But this has some problems with it, because if you had any other actions going on, say animations or background music or anything else, everything would just stop. It'll work, but it's not a very elegant way to solve this problem. The alternative is to actually specify a delay which doesn't interrupt with the rest of the game, but does allow the game states to change as and when we need them to. So we'll still keep the frame rate nice and high, but we'll add in delays that slow down the user actions and the sequence of events. So if we've got anything where we need to control a sequence, you can't really do much better than getting a nice state machine involved. And so that's what we're going to sort out. So, what do I need for a state machine? First of all, I need to get my OneNote up. That would help, wouldn't it? And do you know what I'm going to do? Just before I start doing this, I'm just going to draw... Where am I? I need to find out. I'm just looking at my screen here. I'm just going to draw a box around this. There we go. That's just so I don't draw into that and you can't work out what I'm drawing. If you do want to do any of this on Linux, you can use the SDL version of the console game engine, but to be fair, you could use the Pixel game engine too. You'll see that we've really done all of the drawing now. There's not much to it. But what we are talking about are state machines. And you'll have to put up with my messy writing today. Usually I edit it out if it looks bad. And we're going to have to consider what states are in the game that the user is going to play. So the first thing that we'll see is we'll need some sort of user interaction state. So this is going to be the user moving the cursor around on the screen to select the gems that they want to interact with. That's one state. When they've found a gem that they do want to interact with, we'll need to swap the two gems around. So you select a gem and then you can swap it with the neighbour above, below, or to the left or to the right. Once we've swapped a gem, we then want to check, has it become a winning combination? So in essence, when we're checking gems, we're looking for rows of 3 or more, either vertically or horizontally. If we have had a winning combination, we want to remove those gems from the playing field. Because they've disappeared, you've lined them up, they're no longer relevant to play. Now, this happens to be, so far, our state machine is fairly linear. So this is we move from state user to state swap when the user swaps the gem, otherwise we stay in the user state. But when we get to the remove state, where do we go next? So we've removed the gems. Well, if there's all the gems that have won have been removed, we probably want to, we've got spaces in our playing field, so it's likely that we'll want to compress the playing field down. So if I've removed gems, let me just go back to the reference image. So if I remove this row of gems here, green, purple, purple, which I couldn't do, that leaves a space, and I want all of the gems above it to fall into that space. So I'm going to call that the compression state, where we crush down all of the gems from above. So we'll have compress. I just want to make sure I'm still sort of visible on the OneNote, avoiding all of the obstacles on the screen. However, if the check failed, as in it didn't find any gems to remove, then we go back to the user state. We allow the player to have control again. So in remove, we've got a decision to make. If there are no gems to remove, we go this way, so no gems to kill, we go that way. But if we have got gems to kill, we kill them and we've got spaces. So I'll put gems to kill, we go this way. Once we've compressed, we'll have moved all of the holes in the playing field to the top of the screen. Now we always want to have a playing field full of gems, so we go and add some new ones. But I don't want to just, that says add new gems by the way, but I don't want to just add gems where there's all the spaces. I want to visualize them falling down. I want it, I want the player to feel as if they're playing an action puzzle game. So I'm only going to add a row of gems at the top, and then I'm going to call my compress function again. Or at least enter the compress state again, because if there is a hole and I've put some gems at the top, they'll be compressed, they'll only move down one, so it'll look like they're falling down the screen. If I've added new gems, and it turns out that I've got all of my gems full, I've got nowhere else to go, then I want to check to see if there are any winning combinations again. So you can imagine the situation, I've now filled up the playing field with gems, but I've put them there randomly. There could be all sorts of winning combinations again. That's one of the fun parts of the game, is there's some luck to it. So if I've added new gems and it turns out that some of them are winning combinations, then I need to go through the process again. And so I can sit in this loop for some time. So if I want to add new gems, and my total number of gems is 64, because we've got 8 by 8, check to see if there's any winning combinations. If my total number of gems is less than 64, then I want to compress the ones I've added and move back to the start. We'll start to see this become a lot more apparent as we start the playing. So, given that it's an off-the-cuff diagram, it's not too bad. Let's just quickly run through, because I think it's quite important to know what we're doing with these states. So we've got the user with the user input controlling the cursor. They can decide to swap. I'll choose a different colour. They can decide to swap. After a swap, we want to check to see if there are any winning combinations. And if there are a winning combination, we want to remove them. And in the remove state, if it turns out that there aren't any winning combinations, so there's nothing to actually remove, we go back to the user and let them choose another location. However, if we do successfully remove some gems from the playing field, we want to go into the compression state because there'll be holes. And the compression state decides to add some new gems to the top of the screen. It just adds a single row because we want to see everything falling down. When we're in the add new gem state, if our field is already full of gems, then just double check again to see have we got any accidental winning combinations, and we can sit in this loop repeatedly until there are no gems and we end up back with the user playing. Yes, I think that works out. Okay, let's run with that. Let's have a quick look at the chat after all that. Quite a lot of people in the chat today. Good, good, good. So I think what we'll do first is just construct the basic outline of the state machine and then worry about filling in the individual states as we go along. So in a state machine, one way to do this is by having an enumeration of states and maintaining the state machine with a couple of variables. So I'm going to do just that. And that way we know at any point what particular state we are in, and we can also signal which state we want to go into next. So we've got the user state, which was for the user input. We've got the swap state. We've got the check state. Check, let's call it. And we've got then, what did we have after that? It doesn't matter what order these are in. We had remove, didn't we? I'm going to call that one erase gems. So check is going to flag all of the gems whether they need to be erased or not. And it's actually the state erase is going to perform the erasion of the gems. So after we've erased gems, we could be left with holes. So we need to compress all of the holes down. And then once we've compressed them, we're left with holes now at the top of the screen, so we need to add new gems. So they're all of the possible states in the game, and I'm going to maintain these with two variables, which are automatically the type of this enum, endState, if I can type, endState, and nNextState. Very good. We'll initialize those in our onUserCreate function. So we want the game to start in the user state. Now, I know not everybody is up to speed with C++. If you've not seen enumerations before, that basically these variables are restricted to only containing these values. That's the way to think about it. And it's nice because it's descriptive. So instead of using numbers, which could have different meanings or be you could do operations on them, the compiler makes sure that you're trying to obey some of the rules. So we've set up our very basic state machine. What do we do with it? Well, this is where our gameplay exists, and I'm just going to put in a big switch block based on our current state. So let's just fill some of these in. I'm going to do some creative cut and paste here to help me out. Don't need all of that, I just need those. Very good, and I just also want these to be cases. Oh, I put my thingies in the wrong place there, haven't I? Get rid of those. Tell my fingers are going faster than my brain at the moment. Added some brakes. So there we go. In our gameplay, we can handle all of these states. We also know that we're going to need delays, but I don't want delays to permanently stop the process. So what I'm going to do is only update the gameplay when I'm not delaying for something, but I do want to render the screen every frame, because I've got a feeling towards the end of this I want to throw in some animations to help things along. So I want the animations to occur even though the state changes in the user interaction has delays in it. So I need to implement that I'm going to do that by counting down. Hang on, we've got a flag here. The remove state already assumes that the gems are to remove. So you want to be able to move to user control from the check state, which determines there is nothing to remove. We'll see, I guess. I mean, that's half the fun of doing these things somewhat live. I'm going to need a variable which I'm going to use for delaying, and I'll use a floating point variable. I'm just throwing these things in here for now. F delay time. I'll set that to 0, 0. And what I'm going to do is I'm going to accumulate f elapsed time. So every time this function is called, I get basically the time that has passed between the two frames. So if I accumulate it, I get effectively the transient wall time. So I'm going to do exactly that. If f delay time is greater than 0, then I'm going to subtract from delay time the f elapsed time. Else, I'm going to do gameplay stuff. But I'm always going to do rendering. So now I can set this value to whatever I like, and it will wait for that duration of time. So I can set it for 1 second, 2 seconds, half a second, whatever. If this value has a value that is greater than 0, the gameplay state machine will shut down. Well, it won't shut down, it just won't be updated. So the state of the game doesn't change. It effectively implements a delay. Right, let's handle some user input. Now, the user is going to use the arrow keys to move a cursor around, and I think to select the gem, they should use the space bar, which will stop moving the cursor, but that'll allow you to select the immediate neighbour. So I'm going to need some variables. I'm going to need some cursor variables. We'll throw those in as well. So int n cursor x and n cursor y. And I think I'll just initialize those to 0. So that's going to be top left by default. And let's draw in a cursor at the bottom of the screen. So we want to draw the cursor on top of the field of gems, which is the drawRect function, which is going to pass in a rectangle, and it's simply the location of the cursor, because everything is everything is in screen space quite natively. That's why choosing a low resolution is working out for us here. It's very easy to do a one-to-one relationship between the game and the screen. N cursor times 8 and n cursor y times 8. Make that n cursor x. So this allows us to draw a little rectangle around the gem that the user is currently interested in. I'm just going to draw it as white. What was the color codes for the console game? And color codes foreground. That was it, foreground white. There we go. Let's just see if that looks about the right size. Yeah, so we can see we've got a white box top left around that particular gem. Good. So we're only going to really allow user input in the state user state. I don't like to remove the blinking cursor from the top left. I think that lets people know it's actually running in a command prompt. But then that's just my taste. Right, so we've got two types of movement here, but I want to use the arrow keys for both of them. So let's just first of all get some arrow key movement in. If get key, now it's not OLC keys, it's virtual key codes, isn't it? Yes, so VK left. If get key VK left dot is pressed. I don't want it to be held, else it'll fly across the screen. But as soon as they press it, it's going to move once. Then I want my cursor to move accordingly. I want something similar for right, up and down. Of course, these go the other way, plus plus, and that one's going up, which is negative y, and that one's going y plus plus. But I don't want to go out of bounds, so I also need to check here to make sure things are going in the right place. So if my cursor x is less than 0, then I'm going to force it to be 0. Cursor x is greater than 7, because it's 8 by 8, don't forget. Then I'm going to fix the cursor to be at the 7th location. We'll do exactly the same for y. Let's actually put in the 7 there. Y and 7. Right, so that allows us to move the cursor around. Let's take a quick look. So as I press the buttons, and I can't go beyond the edges of the array. Very nice. No, I'm not simultaneously streaming on Twitch and YouTube. I don't know if these things will run in the new Windows terminal. I imagine that they probably will. Do I have a GUI for the OLC engine? Yes, I do, but currently I'm pushing people towards a fella called Sleeping Bear, who's developed a nice GUI framework and some tutorial videos for using it. But I'll be looking at doing something with my own GUI stuff later on in the year. Will this stream be archived? Yes, as soon as it's finished, it'll remain here on the channel as a video. Right, let's get back to it. Now, what's different though is here I'm moving the cursor, but I want the ability to also select a cell to swap with. And I'm going to do that if the user's holding down the space bar. So I need to be sensitive to the user pressing the space bar or not. So if the user isn't pressing the space bar, then we want to move normally. So if they've not got the space bar held down, move normally. Otherwise, we want to initiate some sort of swap. Which means we're going to need some of this again. So let's just borrow that for now and stick it down there. So the idea is that hold down the spacebar and press one of the keys to select the neighbouring gem you want to swap with. So I'm going to create another pair of variables, which are the swap target location. Swap x and swap y. And so if I'm pressing the left key, then I want to swap with my left neighbour. But I don't want to swap with a neighbour that's off the edge of the array. So I actually need to check that I'm within the bounds of the array too. So I'm going to make sure that if I'm trying to swap and I'm not on the completely left edge, then I can actually swap. In which point I'm going to store in my swap coordinates the cursor location. There we go. And we'll do the same for right. And cursor y is less than 7. 8 by 8 array. Not cursor y. Why cursor y? Cursor x. N swap x equals n cursor plus 1. And we'll add in the same for y. Need an X there, moaning at me. So what this is doing is it's giving me an additional variable, which is my intended swap target. So I've got the cursor, which is the current gem, and I get the coordinate in my array, which is the gem I want to swap with. And so in this state, I only want to change to the next state if these two values are not the same. Because if I'm up against the edge of an array, my swap x will equal my cursor x. So there hasn't been any particular change. So I don't want to change into a new state. So I only want to change into a new state if the cursor and the swap target are not in the same place. So if they're not the same or that's not the same, that's legitimate to allow me to swap. And I'll do the swap by setting my next state variable. There we go. Yeah. Good. This is going to be a Bejeweled style puzzle game. Why do I prefix variables? I like to know without looking at them or requiring the IDE to tell me or trying to remember what I specified in advance what type they are. Simple as that. It just allows me to read things a little bit quicker. So we can move the cursor around and we can now initiate a swap. So what do we do in our swap state? Well, we know that regardless of what we do, when we leave swap, the next state is going to be our check. And I also know that I want the swap to take a period of time. So I'm going to set my fDelay time value to some number of seconds, in this case half a second, because I want the player to see that the characters have indeed swapped. How am I going to swap the characters round? Well, the gems, sorry. How am I going to swap those around? Well, I have, according to the standard library, the ability to swap two things around. So I'm just going to simply call the swap function on my gems array from the cursor location. With my swap target location. That's a nice little function to have. If you're not familiar with this function, it's quite a useful thing just for transferring the variables, transferring the values between two variables. We're coming up to the interesting state in a minute, which is where we're going to check for winning conditions, and we'll get to that in a minute. But what I do want to know, I think, for now, is if we have the swap, I want the player to be able to swap the two gems and visualize them, but the swap might be able to fail. It doesn't actually result in anything winning, in which case I need to swap them back at some point. So I need to keep a flag of whether or not the swap has been a successful thing. So I'm going to throw that in up here. We'll call it swap fail. Give that some value. So I just want to set that here that there's potential if this value changes. Then I just want to swap back my cursor and my swap target. Yeah, I think that's right. Okay, so what I think now, before we get into the more complicated states, I'm going to do the compression, I think, because basically that's always the same. There's no situation where we're never going to want to compress the screen. Let's just quickly throw up the OneNote again. So what do I mean by compression? Well, let's take a smaller grid of gems. So here I've got a gem, here I've got a gem, gem, gem. I'll not put a gem there, gem, not put one there, not put one there, and have another row on the top. So I've just removed this row of gems. There was 3 in a row. They've been successfully removed from the scene. That leaves an empty space. But I need the gems above it to fall down into that location. But I don't want them to just fall down straight away the entire distance. I want the player to see them falling down, or else it'll become quite confusing. So I only want to move gems 1 row at a time. So this one gem here is going to move just 1 row below, and so will its neighbour, and so will its neighbour, which means on the next iteration all we've done is move the space up a row. So I can make a rule that if any gem has a space directly below it, then it moves into that space. And eventually this space will propagate its way to the top of the screen. Leaving the space up here, and we'll get to it later, but that's where we can check to add new gems. Ugh, lost my cursor. Where's my mouse cursor gone? It's because I put my drawing tablet pen on top of the drawing tablet. Come on, OneNote. What's going on? Needed me to right click for some reason. There we go. So I'm going to now go through all of the gems starting at the bottom of the screen, and if they have space below them, it's going to move into that space. And that's always going to happen in the compressed state, and that's all it's going to do. So starting towards the bottom, and you'll see I'm not going to start directly at the bottom because I know any gems on the bottom of the screen aren't going to fall down. So I'm actually going to start from the second row from the bottom, which happens to be row 6 in our array. So if y equals 6, y equals 0, y is greater than or equal to 0, y minus minus. So it's one of these reverse for loops, which are always a little bit more fun. I'm from Northwest United Kingdom. And we want to check now all of the gems on that row, so I'm going to scroll across them with an X, and this one's a bit more conventional. X is less than 8, X plus plus. And all I'm going to do, I need an int there, don't I? All I'm going to do is check if this is a particular gem on that row. If the gem immediately beneath it has an empty space, then I'm going to swap the 2 gems around. So this is interesting because it's just made me think of something. How do we actually implement empty space in our program? We've not done that yet. So I'm going to add to my struct a flag, bExist. Yeah, so that tells us, has the gem been removed or not from that location? Okay. So now I can check if the current gem exists and the gem immediately below it doesn't exist. It's gems, isn't it? Not gem. Gems. And because I've used a 2D array notation here, that one's much easier to do. So if the current gem exists and it doesn't have anything underneath it, then swap the 2 around. And because if one of them doesn't exist, we're actually swapping the fact that it doesn't exist. So it'll move that non-existence up the gem array. It's getting quite philosophical here. So we'll swap X and Y with the one immediately below it. There we go. And I think that's all we need to do to compress the gem, other than to say I don't want it to all happen immediately, so I want to throw in some delay as well. Let's say 100 milliseconds for each stage of compression. Once we have compressed, we want to go into the new gem state. That's what we've just seen in the OneNote. So the next state equals state new gems. So that's going to go through all of the rows, starting from near the bottom, working its way up, and move all of the gems that have spaces below them 1. So that will have moved lots of spaces up. They might not all necessarily be at the top, but eventually they will get towards the top. So in our new gems function, we really only want to add gems if there's a space there. So they don't, as in, we want to check if the gem exists on the top row, and if it doesn't, that's where we want to inject a new gem. Okay, so I want to scroll across the top row this time. And we want to check for the gem's existence. So if a gem doesn't exist, X, and I can just simply say 0 in this case, because I'm only checking against the top row. Gems, come on David, get it into your head. Gems. If the gem doesn't exist in that particular location, then I actually want to set a gem there. Gems x0 dot b exist equals true. And because I want the gems to be new gems, not just reused gems, then I probably need to specify its colour again, don't I? So in my initialization loop up here, I'm just going to borrow that and stick that down here. And I'm also going to have to tell it whether the gems exist or not, aren't I, to start with. So let's throw that up at the top in our initialization loop. And I'm going to say that none of our gems exist. So the game will start by trying to fill up the game board. That might look quite pretty. Maybe. We'll see. Let's see what the sequence of events is. So we've got some user stuff going on, but we don't want the user to have any interaction if there are any spaces on the board. That's quite important. So I want to keep a counter of how many gems actually exist. Total gems. And so in my state machine, if I've got less than 64 gems, then I don't want the user to have any input. The sequence of gems falling and things is needing to take place. So let's add that in. So if total gems is less than 64, then the next state is equal to, we want to add some gems, don't we? Is that right? Let me just check. I've got a doodle of a state machine here. If it's less than 64 gems, well, we want to sort of send it to the compression state. That's what I've got here. So if we've not got the full amount of gems on our board, we'll send it to the compression state, because that will then feed into the new gem state. So state compress. Else, we want to do user input. There we go. So I'll just go back to the OneNote and add in that additional branch. So what have we just added here? Basically, we've added another branch which says if the grid is not full of gems, then go here. So that's total gems is less than 64. So we've got less than 64 gems, we go to our compression state, which also checks if we've got less than 64 gems, adds new gems, and that goes around in a circle, compressing, adding, and adding, until we've got a full field of gems, in which case control is returned to the user. But that's going through the remove state. So let's have a look at what the remove state needs to do. Right now, check and erase don't do anything. But erase is probably always going to, well, it doesn't always go to. Let's have a look at the OneNote again. What did I say it does? It either goes to the, oh no, it does. It goes either to user or compress. Thank you guys for all of the supporting comments there. Yeah, and full disclosure, I am prepared for this. I'm not doing it off the cuff at all, because I just don't think it's a particularly entertaining video to watch me fumble through trying to do all of this for the first time. So I do actually have some notes and some things that I've been trying. Whenever we've done a check, we can fill in the rest of the state machine, can't we here? So check always goes to the erase state. So we'll throw that in at the bottom. State erase, and state erase, have a look at my thing again, is basically how many gems do we want to remove? Well, we currently don't have a track of how many gems we want to remove at the moment, do we? We're not that far yet. Anyway, what we do know is that the total of gems when the game starts will be less than 64, at which point it goes to state compress, which will move up empty space if necessary, delay for a little bit, and then goes to add new gems. State add new gems doesn't seem to go anywhere right now. And that's because we want to, if we've still got spaces, we just want to go back to compress, don't we? Yes, that's it. So, if n total gems is less than 64, just go back to add new gems. This is in a way, yeah, I don't know, we'll have a think. I'll throw in some timing here, and we'll see what it looks like. Total gems is less than 64. We want to go to state compress. It's all fun, the state machine, because you have to code quite a bit of it before you can start running any of it, which is it's fun for the programmer, but not so fun for the viewers. I'm aware of that. However, if we've got a full field of 64 gems, then the safest state to go to is the checking state, isn't it? Because we've got added new gems. These gems could be part of winning combinations, so they need to be checked again. State check, and then we break. So all of this so far is just our little state machine. There's not very much to it, and I don't think there'll be much more to it really, other than the logic for checking the winning conditions. But whenever we've assigned something to next state, we then need to assign it to the new state for the next time round. And got to remember, this here is actually the end of the gameplay section. Right, I'm going to click compile. And we'll see what happens. Okay, that was quite interesting. So why did we see all sorts of stuff appear at this start, and then we saw stuff fall down? Ah, and that's why, because I only told the top row to not exist. That made absolutely no difference. Why was that? I want to set all of my rows to not exist. Set all of my gems to a particular... Ah, okay. That's because we're drawing something regardless of whether it exists or not, which is no good. Thank you, Speedy C. They're always a bit nerve-wracking, these things, doing them live. So the problem I've got here is whether the gem exists or not, I'm insensitive to it. I'm just always drawing something. So I only want to go through this drawing procedure if the gem in that location actually exists. So if it exists, gems, be burnt into my brain by the end of the night, that. If it exists, then we draw it. If it doesn't exist, we don't draw it. Hey, right. Good. The celebratory glass of water. We've got that far. But what we can see now is we need to start implementing the actual game logic, because there's already quite a lot of winning combinations on this board. We've got a row of 3 reds, a row of 3 pinks, another row of 3 reds, 3 greens, We've got a horizontal row here of cyan. So they're all technically winning combinations. So they need to be automatically discovered and, in effect, removed from the game, creating some holes. Let's make sure I can still move the cursor around. I can't still move the cursor around, which tells me I'm not in the user state. And I won't be in the user state because my total gems is not less than 64. So if my total gems is less than 64, it's 0 at the moment. So I'm just looking. So you said it as I typed it. That's okay. I thought you were streaming, Gareth. Right, where am I up to? So my total gems value I've initialized to 0, which means it's never going to actually go into the user input state. So I want to, whenever I add a new gem, increase my gem count, don't I? That seems like a sensible place to add such a function. So here, n total gems. Now, hopefully, once all of this is run, that value should be equal to 64, which means in my user state, I should gain control again, and I haven't, of course. This is the fun of live. So why is my total gems not gone up? I don't know. Total gems is less than 64. Do a delay, stay in that state or not. If Javid can add animated sparkles, he's a boss. Well, thank you, Gareth. Just need to work out why my gems are not the right number. Why not? Will we do some live debugging? Total gems is less than 64. Go into state compress, or we go into user. So my total gems is not adding up to 64. Why not? So by the time I get back up to here, let that all settle down. Oh, we've simply not entered the user state. Well, that makes some sort of sense, doesn't it? Maybe useful to actually display what state we're in on the screen. So how did I get back to my user state? The playing field will look the same each time because I'm just using rand and I've not seeded it with anything. So the same random numbers will be generated each time, which works to our advantage because as we're testing things, we might want to repeatedly run the same tests rather than relying on trying to find the winning solutions. Right. I'm going to go to my state erase now. And think about how do we remove gems which have been flagged to be removed. And of course right now we don't really have any flag to say that a gem should be removed. So I'm going to go and add one to my struct. Because we've got a way of adding gems which is increasing our total gems count, I'm going to use the erase state to decrease the total gems count. And I'm just going to go through the entire array because it's only 8 by 8. I'm going to copy some code to help me do that from down here. I'm going to go through all of the elements in the array and see if they have been flagged for removal. And it's going to be this checking state, which is the most complicated state, and that's why I'm leaving it till last. If the if the gem is flagged for removal, then all I want to do is set its existence flag to false. And I want to make a distinction between a gem being flagged for removal and a gem actually existing or not. They're not the same thing because a gem being flagged for removal we can draw differently on the screen. So again, it's giving some feedback to the player. But once it gets to this state, any gem that has been flagged for removal is when we actually remove it, and we remove it by setting its exist flag to false. But we also need to decrease our total gem count. Whoa. No, I don't have a mechanical keyboard. Thank you for all of the people that have shouted out some support since. Once we've erased things, then we've got to go into the compression state. So the next state is compress. So we've removed things, we're probably going to have some holes. Space these out a little bit, sort out my formatting. Right, where are we up to? For some reason we were never getting back into state user. Let's just consult the state diagram again. What gets us back into state user is really just from the erase state. Is that right? Have I already made a mess? No, I haven't. The one thing that we've not considered here is a slightly strange scenario, so I'm going to code it in. What's my opinion on chili tomato noodles? Good stuff. There's quite a few people on the Discord using his some of his game engine thing. He did something not dissimilar to the Pixel game engine, didn't he? Or before I did the Pixel game. I don't know which is which. Right. To get back on track. Let's start thinking about what we're doing in the event of a swap. So I want to get to a point where I can see the swap occurring. I'm not going to check if it's a winning combination, so that's going to go straight through to erase. There are no gems flagged to remove, which is going to go straight through to compress, and compress can go to new gems, and new gems can only go back to state compress or check. It never gets back to doing any user input. And I think this is where we're starting to fall down a little bit. So I'm going to say that in our erase state, if no gems have been flagged for removal, then there's no need to go to the compressed state. There's no need to go and add new gems. We can just return control back to the user. So let's add another flag, flag for removal. We'll set that to false. So if there are no gems to remove, and we'll know if there are gems to remove because when we're checking them in the check state, we can set this flag. So if there are no gems to remove, then go to the user state. Otherwise, do all of that. I'm just going to make sure I can compile that and run it and see what happens. But we should have an entryway back to our user state now. Yes, we do. Excellent. So I've got control. We're now in user state. So we saw the gems fall down. That was quite nice. The compressing and adding new gems seems to be working. We're now up to the swap. So if I hold down space, you see something strange going on there when I hold down space. And that's probably because I'm ping-ponging between two different states, I imagine. Thanks, guys. Imagine we might have a few new faces on the Discord server later tonight. Right, I'm going to, just to keep things moving, I'm going to have a quick look at my notes here just to make sure I've not missed out anything particularly important. We've done the state user, we've done the state swap. State check we're leaving to last because that's got some complexity to it. State erase, we're only removing gems if we need to, otherwise we go back to user input. Or we remove the gems. Now we can compress them and go back to state new gems and add new gems. And if we don't need to add new gems because we've got a full field, we go back to our check state. Okay. Right, one of the things that we haven't included here is what happens when we do fail to swap. So let's say we perform a swap, but it doesn't cause any gems to disappear. It's a failed swap, in which case we know we're not going to have any gems to remove. So I'm going to be sensitive to that here. If b swap fail. If we have failed to swap, so this remains true, because we set that here. If this remains true, then I want to swap back the original swap. I'm really satisfying how the gems fall down like that. Okay, so that's swapping with something fairly random. Okay. If n cursor is greater than 0, then it's less than 7 for sure. I don't know where you've seen that. If n cursor is greater than 0, then it's less than 7 for sure. Fix that. If n cursor x is less than 0... Yeah, I don't see where you're seeing that in the code. If n cursor y is greater than 0, then it's less than 7 for sure. If n cursor y... Ah. Oh, that's okay. That's okay. That's okay. You didn't set the swap x and swap y to current cursor positions, did you? Didn't I? Ah, I see what you're saying. Okay, and that's why we're getting that swap to the 0. Well spotted. Who spotted that? You get extra points. The Killjoy. Excellent. Quite right. So who knows what swap x and y were resolving to at some point. Okay, so let's try a swap. Pink to green. There we go. And it lasts for, well, a fraction of a second, and that's because of the build times. So now it looks like we're getting somewhere with the swapping. I guess we're up to the point where we need to start checking for winning combinations of 3 or more horizontally and vertically, and then flagging them for removal. Getting there slowly. So the Killjoy, extra special points for you. Yeah, this is going to be just like Bejeweled, hopefully. Right, so let's do that. Let's start thinking about how do we remove the cells. So we've got the swapping mechanism set up. We've got the ability to add new cells. We've seen them. We've not seen any cells get erased yet, so we may have some issues there. But now we want to go through all of the states, all of the cells, and check to see after a swap, is there a winning combination? And I'm going to do this brute force. I'm not going to try any tricky flood fill algorithms or anything like that. All I'm going to do is start, I'll say here, and I'm going to count. I'm going to get the value or colour of that particular cell, and if my neighbour is the same, I'm going to add 1, and I'm going to keep adding 1, providing my neighbour is the same colour. And then once I've got that for a full row, I know if I've got a winning combination or not. I could try doing clever flood fills and things, but I really think this is a simple way to do it. So I'm just going to go through the entire array. I need my x's and y's again. X's and y's. There's probably some really nice way to automate this with the standard library. So let's go through everything, and I only want to check for gems that haven't already been flagged for removal, I think. So maybe I actually need to say that right at the start, don't I? B gems to remove is going to be false, because if we were checking, then we know that we may have some gems to remove, but currently there aren't any gems to remove. So that's good. And I only want to check gems which have not been flagged for removal already, because as I'm scrolling through the array, I'm going to be setting some to be removed or not. I don't want to check them twice. Okay, yeah. If gems x and y dot be remove, so if the gem hasn't been removed, it exists somewhere, then do your thing. Oh, I put an extra bracket at the end there, didn't need that. And the first thing I'm going to do is check horizontally across the array. And then I'm going to check vertically. And what we'll see is the code for these is probably going to be quite similar, except the coordinate positions will be changed around. So I want to create a counter which counts how many successive cells are the same. I'm going to call that a chain. And I guess the chain by default has a minimum length of 1, because a gem on its own is in a chain of size 1. And so checking horizontally, what I'm going to be checking for is the current gem's position, x and y, and I can identify the gem. Its unique identifier is its colour. So it's grouping the gems together, which is the important thing to do. So if the colour of the starting gem is equal to its neighbour, and I can do this by x plus n chain, because what I'm going to do is grow the chain until this condition is no longer true. So if that's no longer true, you put my dot colour in there. Spell colour the proper way, by the way. So whilst the current gem is equal to its neighbouring gem in colour, I'm going to increase my chain. But I just need to be careful, because when I get to towards the edges of the arrays, this chain could be quite large. Or can it? I don't know. I'm going to throw in some safety checks here, because I don't want this to fall over. So if I say that n chain plus the current x coordinate, it's all of that is less than 8. So that's just going to keep me in bounds. That's going to stop chain from increasing beyond the horizontal width of the array. And so that's quite nice. The new people are starting to wake up on Discord. It just got harder. Okay, so I've checked horizontally, and in one single line there, I've now built a chain which will stop as soon as the gem becomes a different colour from the original gem. Okay, that's good. That's nice. I like that. And we're only interested in chains that are greater than, well, equal to or greater than 3. Because just getting a chain of 2 blocks isn't enough. So if the chain is greater than or equal to 3, then I want to flag all of the gems in that chain to be removed. And I can do that because I know what the length of my chain is, I can work backwards now. The chain the chain variable has been set. So if, in this case, gems, I'm going to think of my array indices here, plus the current chain value, take 1, y, no, what am I doing? What am I doing here? So if the current gem's x position plus the chain minus 1, because the chain started at 1 and our array indices started 0, then yes, this is correct. There's no if here, and that's what's confusing me. I just want to actually set that to be flagged for removal. Okay, so if my chain is greater than 0, I flag it for removal. And I want to decrement the length of my chain, of course. The swap hasn't failed, so that becomes false. It's been a successful fail. It's been a successful swap because we've removed some gems, and because we've removed some gems, I can set my gems to remove flag to be true. Okay. Let's just see if that works. Let's see where we're up to with this. Just click play. Now we're only checking in one direction at the moment, and it was horizontal. So if I swap there, excellent. Okay, it was all very quick, and I don't think it was entirely accurate, but the horizontal cells did move about, so something happened. It doesn't work for vertical yet because we're not checking vertically. So have I got any other horizontal winning combinations? One down here. Well, what we can see then, at least we can punch holes in the array and it's filling up with new gems. Whether or not it's accurate is something we need to check on. I think I'll add in the same code for the vertical check because it's going to be pretty much the same. To be fair, you don't like T. You don't like T. Don't know how I feel about that. So once I've done check horizontally, I'm going to do exactly the same for vertical, except this time all of the good stuff is happening in the y-axis instead of the x-axis. Chain.y. And this one becomes y plus n chain minus 1. So I really am just brute forcing it through. Let's see what happens there. Oh, we got an automatic win condition there. So it automatically checked something and removed it. So I want to find just a simple to understand what's going on vertical check. So the pinks, so something happened over there, which was a bit strange. Okay. I think we're removing all sorts of things here. It looks like I might have some index problems in my math somewhere. That should have been a win. Okay, we're battling through this one. Should you not check the bounds n chain x before you access the index? Not quite sure I follow there. So let's just see what's going on here. So I'm going to check against these horizontally whilst I'm staring at the chats. Check these horizontally. And I'm increasing the length of my chain. This is what's protecting me from going out of bounds on my my access here. If chain is greater than 3, then whilst chain is greater than 0, go through them all, set them to be removed. Oh, the problem we've got here is the remove flag. when I'm placing a new gem, I've not set its remove flag. In fact, I don't think I've set any of the remove flags, have I? Let's just see if that helps a little bit. So it was removing gems where I'd already won. Okay. Okay. There's a win. 1, 2, 3. So I'm just exploring the map and seeing if I can visualize if it makes some sense what's going on. There's one. And this yellow is for those 3. And then we got a secondary one at the top. The mechanics seem to kind of be working, I think, he says optimistically. Quick look at some of the chats. Yeah, it feels a little bit more bejeweled. Oh, hey Lucas, didn't see you there. Why have the grey gemstone removed for? Well, I don't know what the situation was when we played the chat, but I think that's kind of working. So, what else does? See, we get something interesting going on there. So. Yeah, there's something curious going on there because I think there was a bit of a change of colour and whatnot. Never mind. We'll keep going anyway. See what we get doing because I think I want to add sort of the next part to this. Well, I don't think might add a score system to it, but I think what I'm going to add to it next is the ability to add bombs. So this is one of the problems you'll find in Bejeweled is very quickly you'll just run out of options. I don't want to spend tonight going into the algorithm to make that happen with lots of interesting algorithms to actually make it always winnable. I'm not prepared to go into that tonight. But what I think we can add is bombs to erase large chunks of the map. I'm just going to add in, at the end of the check state, a small delay so we can actually see what's going on. So if there are gems to remove, then f delay time equals, I don't know, 3/4 of a second. Let's have that. Let's just see. Because what was proving a bit difficult there is I couldn't really see the gems that were winning. There we go. That slows it down a little bit just so we can see what's going on. Ah, so that's why I thought there was a problem down here, because I didn't realise that formed a row of 3 pink. Tell you what, let's make that more visible. Oh, yeah, so lucky. I wish I had a Net Eurosi. I remember asking for one when I was much younger. They came out. They were very expensive. I really wanted one. Parents decided to get me something else instead. And parents, if you're watching, doesn't matter. Don't worry about it. What I want to do is actually indicate to the player which cells have been tagged for removal. I'm going to draw them slightly differently because that way I think it'll be more visible to the player, because I didn't catch. I thought there was a problem or a glitch, but it wasn't. It's because too many things happened at once. So I'm going to choose the shading based on whether the gem has been selected for removal or not. So if the gem is removable, if it's been flagged for removal using a quick ternary operator, then I'm going to set that to be pixel quarter shaded. So it'll go darker if it's been set quarter. So just by throwing that in there, we'll change the shading of the pixel, and that might make things a little bit more visual for us. Yeah, there we go. So now we can see where the winning combinations are. So what happened before is I flagged these 4 grey ones, which caused a subsequent pink one to appear. Nice. Okay, and this is one of the reasons why a state machine has made this very easy to work with. The timings were all customizable, and just how we can go about structuring the sequence of events has become quite customizable too. So that is actually looking a lot more bejeweled. I like the fact that it sort of automatically settles down as well. Right, let's add bombs. Bombs are good. Watch YouTube blacklist me now for saying that. So I'm going to add another type of sprite. Because adding a bomb to this, I think, is very simple indeed. What we're going to do, where have I put my sprite for my gem? There it is. We'll have another one called SBR bomb. And we want to draw something that looks sort of like a bomb. So I'll just borrow you for a second. So you get a bomb or an exploding gem if you get 4 or more in your chain. So it encourages you to work a bit harder. Sprite bomb, and I want them to be quite visually distinct, so I'm going to shade them differently. Let's get rid of you and you and you and you and you and you and you. There we go. So I'll make like an asterisk type shape. Get rid of you two and you two. Get rid of you. Get rid of you, you, and you. There we go. An asterisk, which is going to represent bombs, and we're going to place bombs. Oh, first of all, I need to add to my struct, don't I, that it is indeed a bomb. Bomb. And what I want to check is, have I got a chain of greater than 4? Because that's the only time I want to place a bomb. I don't think I'm going to have time tonight to worry about doing things with chains of 5. So what we'll do is we'll just focus on doing things with chains of 4. So here I check for, is it greater than or equal to 3? And if it is, fine, we get rid of the chain. I'm going to make it check for if it's greater than or equal to 4. If it is, then how do I set the bomb? I don't want to set a bomb for every single element here. I only want to set it once. So I don't want to set it for everything in the chain. I just want to set it for the one thing in the chain. I'm going to need a flag to handle that. So let's stick a flag here. Bool b place bomb equals false for now. Boom. Bomb. So if the chain is equal to 4b place bomb equals true. Oh dear. And whatever we do for the x-axis, we also want to do for the y-axis, I suppose. Same rules apply. And so once I've got my flag, I'm sensitive to it. I know one guaranteed cell in that chain is the one that I'm starting with the check. So that's the one I can turn into the bomb. So if b place bomb, then gems x and y dot b bomb equals true, but I also don't want to flag it for removal, because it will have previously been flagged for removal. It's part of the chain. I don't want to do that because it's now a gift that we're giving back to the player. So I'll get rid of that remove flag. We now need to choose whether to draw a bomb or not. So somewhere down here in the drawing of the update of the field, right now I'm directly indexing the gem. I need to choose between gem or bomb depending on whether it is a gem or a bomb. And I'll do that by just throwing in a quick reference. Sorry if my mic has moved slightly out the way. So we'll call that source, and we'll set that to one or the other depending on what the state of the bomb flag is. B bomb. So if the bomb flag is set to true, then the source is going to be, and I'm not going to copy it, so let's do this right. Put a reference in there. If it's a bomb, then I'm going to choose the source material bomb, or I'm going to choose the source, which is a sprite. So depending on one or the other, we should see a difference in design. Let's have a look. Now, fortunately, because of rand, we know that we get this convenient for win here. So let's just try that. It didn't get set to a bomb. Why is that? But it didn't erase the first one. Oh, because I didn't change the didn't change my source there. Oh well, these things are meant to test us, aren't they? Let's try that again. There we go. So one of them got converted to a bomb, and now that can be used, because remember, we're only forming chains based on colours. That, in principle, can be used in something else. So we now need to consider, what do we do? Oh, caused all sorts of chaos there with that one. What do we do when we detonate a bomb? Well, we want to remove the immediate surrounding neighbours, so it becomes a bit of an explosion. Oh, hey, Peter, thank you for joining. I'm pleased that you managed to get along in the end. Right, so what we can do to detect, whenever we include a bomb in a chain, we want to immediately remove the 3x3 neighbourhood around the bomb. It doesn't matter what colour they are, we're just going to set them up straight away. So I'll go back to my check routines. And whilst I'm flagging the bombs to be removed, whilst I'm flagging the gems to be removed, that's where I can check. If one of them is a bomb, then I can set the immediate neighbours to also be removed. Is that right? Yes, that's right. Okay, so let's do that. If the gems, get it right, if the one that I'm currently analysing, which is in this case y plus n chain minus 1, if that is set to be a bomb, then I want to do something to my surrounding neighbours. So I'm going to need a small set of for loops. I'll use I and j, and I'm going to use a negative for loop notation for this as well. So for int I equals -1, I is less than 2, I++, because this is going to give me a 3x3 neighbourhood centred on the bomb. For int j equals -1, j is less than 2, j++. And then I want for these items to set them all to be removed. But I don't want to go out of bounds of the array again. Oh, flipping heck. So I've got my 8x8 array, and I want to make sure I'm within the bounds. So I need to do some boundary checking here. So I'm going to create two little temporary variables, int m. And rather than throwing all of this with a complicated set of ifs, I'm going to use min and max to do some boundary checks. So we can do like a clamp function in one hit. So if the minimum of the maximum of I plus x in this case is... I have to quickly glance at my clamp thing. I'm aware of the time, you see, so I don't want it to run on too much longer. It's 7 and 0. Right, so that will clamp. Have I got enough brackets in the right place there? One too many. That will clamp if, first of all, looking at the max condition, if my current cell plus the I value is less than 0, it'll give me 0. So that clamps it on the left-hand edge, and then we go on to clamp it on the right-hand edge. But you notice I'm getting a little error with min and max, and that's because the console game engine includes windows.h, which doesn't tidy up after itself. And it defines two macros called min and max. There we go, it's happier with that. And we need to do the same for y, of course. which is J and Y. So that's going to clamp my two values. It's not just Y though, is it? It's this horrible cluster of Y. There we go. I'm conscious of things like this. I'm just going to throw that in brackets just in case. So that's going to make sure I've got a within bounds element, and I want to set that particular gem to be removed. mn.be remove equals true. So basically, if any of the elements of our chain happens to be a bomb, we're going to remove the entire 3x3 neighborhood around that bomb. And whatever I've done for the, in this case, vertical axis, I want to do in the horizontal axis. Have I got these the wrong way round already? No, I haven't. That's good. So where's that live? That lives just underneath there. But we'll need to just quickly whiz these around to make them compatible. N chain -1. And the same down here. That becomes x plus n chain -1. And that just becomes y on its own. So that's quite nice. So we do that for horizontal and vertical. I appreciate there's some redundancy going on here. I'm sure there's a nice tidy way to make this all very clever, but not tonight. Let's just see if that's happening. Let's go and try and use a bomb in something. Fortunately, we know because we've used rand, we're going to get a bomb fairly close to the start. But just to make sure it doesn't disappear straight away, I'm going to change there. So there is our bomb. Oh, how many times do I have to play in order to make this work? Oh, not too bad. And so now if I include here, we should see the entire neighborhood changing around there. There we go. Oh, we've got some more bombs up here. It's the only problem when you start introducing randomness in your games. There we go. So that removed a 3x3 section around the bomb. Did it also become a bomb itself? I think it might have done. And that's probably because when I'm removing the gems down here in my erase state, when I add new gems, certainly they're not going to be a bomb. So we'll set that to false. And I'm just going to throw the same thing in there just to be safe. It's probably not necessary. That once we've set it to be erased, which, yeah, we're in the erase state, that it is no longer a bomb. Right, so we've got a condition for win of 3 in horizontal or vertical, and we've got conditions for win of 4. We've got falling pieces, we've got nice delays, we've got responsive gameplay because we're not using a thread to block things too much. Yeah, that's working quite nicely now. I've got a feeling before the bomb wasn't disappearing, that it was turning some other cell into a bomb, but I think that's okay now. Let's add some fun stuff. Let's add some visual flair to it now. So it's all very well having things disappear. In fact, you know what? I'm just going to have 2 minutes to quickly look at some of the chat whilst I'm here. You should take a break, lol. Well, I don't want to be here all night. I can feel my voice is starting to get a little bit hoarse now. It's amazing when I'm filming a video, how much of a break you get to take in between different sets. But when it's live, it's a much more different beast. I think what I want to add now is some glitz and glamour to turn this into a crystalling party. I've got to be careful to say a crystal party. But a gem party. I think I want things exploding all over the screen. And it's also tradition that in pretty much every live stream I've done on YouTube, at some point we've had explosions. So I'm going to add that too. And explosions are very simple to implement. We just need to, we were going to implement a particle system, effectively, which is very simple to do. I'm going to create a struct, and my particles, I'm going to call them fragments, because they're fragments of crystals. And they're going to have some properties. They're going to have an x position, they're going to have a y position, they're going to have an x velocity, and they're going to have a y velocity. And they're also going to have a colour. We want them to be the same colour as the crystal that's exploded. And I'm going to maintain the fragments in a list. And not a vector, because I don't know how many fragments I'm going to have at any one point. Things are going to be changing shapes and sizes, so I'm just going to call that fragments. Why have I not got? Let's just get rid of that. S fragment, there we go. So that's going to be a list of particles. So I'm going to need some auxiliary functions to generate these particles and draw them on the screen. Well, drawing them on the screen is very, very simple. I'm going to do that right down here in the rendering code, and I'm just going to have an auto for loop, that's what I call them anyway, going through the list. Oh, hey Devtron. Hey Nana, good to see you here. I didn't see you there. I'm just going to make Nana a mod there. Use the power wisely, Nana. Right, so what I'm doing is I'm drawing all of the fragments that are going to be representing crystals exploding all over the screen. And this is very simple because they have an X and a Y location. I'm just going to plot a pixel at that location. Don't forget, it's low resolution. Shouldn't be too much of a problem for us. Pixel solid, and the colour of the fragment is important too. That way we know which fragment belonged to which crystal. Because this physics is purely cosmetic, I don't care where I do it, I'm going to use the same loop to also implement the movement, the dynamics of the particle. So I'm going to take its position and I'm just going to integrate its velocity with respect to time. And I'm going to use the f-elapsed time variable to do just that. And whatever I do, well that's just rubbish, come on, we can type better than that. Whatever I do for x, I also want to do for y. But I don't want an indefinitely never-ending list of particles. It will get really big because particles are cool. You want many of them. But if I don't get rid of them, I'll eventually consume all of my computer's memory, providing you want to play that long. So I want to remove any particles which are no longer on the screen. And to do that, I'm going to use remove if, which is part of the standard library, and that will iterate through my fragments list. Starting from the beginning, going to the end, and I'm going to pass into it a little lambda function to handle the removal for me. I'm just going to move that down there because it just makes this a little bit easier to see. Basically, it's going to be generic lambda. What's it going to pass in? Well, it's going to pass in a const reference to that particular struct. So s fragment f. And what I'm going to do here is just check to see if it's out of bounds of the screen, I want it to return true. So basically the remove if function will apply this lambda function to all of the elements in the list, and if it returns true for any of them, it removes it. Now, I've not allocated any memory or done anything like that, so I don't need to worry about deleting. It's all just going to be handled for me. Remember, this is a very simple, top-level little thing that maybe you can go and have a play with. So if the x or the y coordinate is not visible on the screen, I'm going to return true. I'm going to return true. So if it's 0, or x is greater than screen width, or y is less than 0, or y is greater than screen height, return. Forgot my Fs. This is where everybody types F in the chat now. And then people think I'm having a bad stream. There we go. So if it's not on the visible screen, we're going to flag it to be removed, and that should just remove it. So that will hopefully tidy up the particles themselves. And that's quite nice. So I'm doing all of the drawing, all of the physics, and all of the list management sort of in one hit there. Very nice. There we go. So where do we actually want to spawn particles? Well, it makes sense that we spawn them when we remove the gems. So it's going to be in the erase state here, and this is probably the most sensible place. It's where things will get removed ultimately from the game. But I need a little function. In fact, I want a couple of functions to help me out here. Thank you for all of the Fs there in the chat. You're all bonkers. Right, so I'm going to create a small auto little lambda function up at the top here to spawn particles. Let's call it boom, and I want to pass into my boom function an int x for the sort of origin point, how many particles I want to spawn, and the color. There we go. So boom is going to add things to that list. And so I just want to go through and iterate all of the size. I is less than size, I plus plus. So this is how many particles I'm going to add to the list. And I want to create them with random velocity vectors to begin with. Now this means I've got the misery of needing to do things with random floating point numbers. So I'm just going to create a quick function to help me out with random floating point numbers. And if you didn't know, yes, you can have a lambda function inside a lambda function. Random float equals, let's give it that. Let's give it a minimum value and a maximum value. And what we want to do is return. I'm going to use rand to do it, but I just kind of want it to be between that range. So let's just actually get the random bit first, which is rand divided by float of rand max. So that's going to give me a random value between 0 and 1. If I scale that into the distance between the maximum from the minimum and then offset it by the minimum, that will give me a random floating point value between the minimum and the maximum. Good stuff. So I'm going to use that function to generate a unit vector through which to set the velocities. And so I'm going to use a polar coordinate system to start this, because that way I guarantee that I always get a particle on the circumference of a circle. If I just chose random Vx and Vy values, you may find that there's a bias in a particular direction, or things tend to look a little bit square. So by forcing it to be a circle, it's just going to look a lot better. So if I choose random float for my angle, so I want to choose a location within a circle, 0 to 2.0 f times pi. There we go, so that's going to be my random angle. I can then set my fragments to be, well, I need to set them up, don't I? So fragment f, so this is the particle. It's going to start at x. Why am I putting my... because I brought that in as an integer, but this is expecting a float. So I'm just going to cast that over. Float x, float y. Now I want my Vx and Vy parameters, which are going to be functions of the random float. Yes, that's right. A times random float. So now I've chosen the angle. I now want to choose the magnitude of that vector, and I don't want it to be too small, or else particles will be drifting across the screen forever. But I don't want it to be too large because I want to see everything. So I'm going to pick some values to say I want you to move at that magnitude. Let's have a look. That's for the Vx, and so we'll do exactly the same for Vy, which is sine. And finally we need to pass in the colour of our fragment. And then we want to add the newly created fragment to our list of fragments. Fragments dot pushback f. Right, so a whole lot of sort of modern C loveliness going on there with lambda functions and initializer lists. So you may be, why have I not gone through all of the properties individually for this struct? Well, I don't need to. It's so simple the compiler can work out just basically from this initializer list what I'm supposed to do with it. So I want to call my boom function when I'm erasing gems. Boom. X, Y. How many do we want to actually put in the boom? I don't know. How many? 50. And the colour is going to be gems x y dot colour. If he can spell. Right, let's take a look. Well, they're all starting in the top left, so that's telling me something's not quite right there. Let me just double check my maths up here in the float x, float y. Yeah, a lot of the moderators on here are the same mods on the Discord server. So I've chosen my angle. Why are they all starting off in the top left and top? Oh, hey, Trolledwoods. Didn't see you there. Chosen a point on a circle. X and Y. Passing in X, Y, and size. Velocities of sound. Don't know. Where am I drawing my particles? Drawing them in the right place. My maximum and my minimum are placed. You use the coordinates, not the position. Ah! Yes! Who was that? Best form spilt. Excellent observation. You're absolutely right. Extra bonus points to you. I've forgotten what I'm calling my boom function now. Erase. Lost my erase state. There we go. Yes, what I'm doing here is choosing X and Y, which is just the coordinates, so they all appear up here. Actually, the gem's location is that times 8, and that times 8. I'm glad somebody's following along. Boom! Excellent. Let's have a look. Let's get rid of these pink ones. And so, because we implemented delay time the way that we did, even though the sequence of the game in the background is, I'm trying to look for a winning combination, is quite sticky and slow, the particle animations can still take place. And that's because we split the domain in time, and we used a state machine to control one of them, and we're letting the game engine control the other. And so that gives you this nice effect of being able to control these temporal sequences without too much trouble. And at the same time have loads of nice interesting effects. So somebody said they were going to give me £1 million if I added sparkles to the game. I'll you can add that to my Patreon account. And I think that's sufficient as a Bejeweled clone for now. I don't think I'm going to put scoring in. What do you guys think? I don't know what the lag is like on the chat, to be honest. I've not really sort of been reading it in real time. Ugh. My throat's a bit sore. So, we have created Bejeweled. We've celebrated 50,000 subscribers. What I will say... Oh, need to offset them by 4. There's always one more thing, isn't there? Always one more. Yeah, you're right. That's not in the middle of the gem. Fine, okay. You can have that one. There we go. Put them in the middle of the gem. Okay, it does look better. I'll give you that. There we go. Well, let's get that bomb. How do we get bombs? About a minute between the chat and the chat display on the camera. Okay, so there's quite a lot of latency then. Not much I can do about that. So what I would like to say is the prize draw is still available. It's still open and will be for another hour yet by my time, and there's a chance to win some cool prizes. I'm just looking for my link to drop that into the chat. So if you want to have a chance of winning some of the prizes, just fill in the request there and answer the question. I clicked compile and add loot boxes. Yes, and DLC. That's what's necessary next. Listen, I wanted to say a big thank you to everybody that has subscribed. It was about 2.5 years ago. I sat down with my wife and I noticed that there was a lot of programming channels on YouTube, and I thought, do you know what? There's space for a channel which doesn't go into too much technical detail on things, but at the same time isn't so dumbed down that it's just outright patronising. And that's what I'm trying to do, and I believe it's becoming successful with the support and the sheer involvement from you guys. I'll tell you what, whilst doing sort of a monologue like this, I can put myself on big cam. And when I started the channel, I really had no ambition of becoming a YouTuber or anything like that. It was not my intention to grow this kind of following. I was really creating a set of resources to document my projects at the time, and it just turned out that the style and the way in which I do things, people seem to latch onto, and I couldn't ask for anything more. If I didn't get any more subscribers tomorrow, it wouldn't bother me. I'm really pleased with 50,000. I mean, that's just remarkable, and I really like the audience too. I think it's fantastic that everybody's meeting up on the Discord server. People are debating in the YouTube comments, and nobody's pulling chunks out of each other. Everybody is just getting on with it and helping themselves and helping each other. And I think that's so important to this community. I have added to the One Lone Coder website a section for showcase submissions. Now, long-time viewers will be aware that I do community showcase videos where I like to show your projects and your code. Rather than doing a video announcing that, I'd rather people submit it to me now via this form, and it'll get a permanent place on the website as well as being made into a YouTube video. And I would like to do one of those over the summer because we're well due one. So if you've got any projects or things you've been working on that you'd like to be shown to the rest of the community, be given a bit of a platform, get them to me. There is a link on the Discord, and I'll put something on the YouTube somewhere else. There's actually a submission process now, and it'll also get a permanent home on the website rather than a rather transient form it is on the Discord server. What else? Anything I've got to say? One little thing, it's a bit of a down note to end on. You may have noticed, some of you, if you're recent subscribers and you're wondering what all this is going on about, that I've removed one of my videos that was picked up by the YouTube algorithm recently. I've removed it because it was not up to the quality that I now expect of the channel. It was dormant and forgotten about, and for some reason the YouTube algorithm had picked it up, and I'd never felt comfortable with it. I'll be remaking that video very soon, and at the end of that video I'll explain all the reasons why I wanted to change it, because I wasn't very happy with some of it. I don't think I've got anything else left to do today. I think I'm pretty pleased that we've made Bejeweled. I'm pretty pleased with the audience numbers, and thank you all so much for the support. I've no intentions of stopping anytime soon. I've got another Car Crime City coming up shortly, and then I've got something else, and then I'm going to take a small summer break just to take a weekend off, and after that I'm coming back with something that's particularly special and very personal to me, and that's going to be a fantastic series with which I think we'll end the year. And I think on that, if you want to come to the after party, hang out on the Discord server. I'll also keep the YouTube chat up for a bit. thank you very much, guys. And good night.